Hello, my name is Clifford Jordan. I'm with Science Foresight, and we're going to be going right now, starting this new series on linear regressions. And this is a new data science series. We're going to have several data science series talking about other different types of topics in data science, but this one is dedicated to linear regressions. And you may ask, why linear regressions? Well, if you're going to be studying data science, linear regressions are kind of like the core thing that you need to learn to understand everything that comes after. If you're going to be understanding stuff like decision trees, Bayesian theory, if you're going to understand all these other more complicated algorithms, statistical algorithms, you need to start off by understanding the basics. And the basics is linear regression. After linear regressions, there's logistic regressions, and then after that, there's all this other stuff that has come along and enhanced data science tremendously. But you need to start off with the basics. You need to understand the linear regressions, and that's what we're all about here. Before we get started, I wanted to point out there's a couple of things that you need to know before we get into this, and one is called you need to understand the slope-intercept formula. This is, if you don't understand, well, y equals mx plus b, if you don't know what that means, if you don't understand what a trend line is, I have another video on that you should watch first. It's 15 minutes, but it'll help you. It's a good precursor to get you to understand what this is. And you need to know this before we can get into linear regressions. The other thing that you need to know is normal distributions. So I have another video on experimenting and understanding what is a normal distribution. This is very important also in understanding linear regression. So if you don't have a good understanding or a good feel about normal distributions or the slope-intercept formula, please go watch those other videos and come back here and go ahead and start the linear regressions with us. This is our tutorial on linear regressions, but before we get there, let's talk about the history of linear regressions. Linear regressions actually was invented or discovered, however you want to think of that. It was discovered by Sir Francis Galton, who happened to be the cousin of Sir Charles Darwin. Obviously, they had a family where math and science was very strong. Sir Francis Galton was into heredity genetics at that time, and he was contemplating the inherited characteristics of sweet peas. And during that, he came up with this idea of trying to determine trends trends based on like a scatter plot of data. So I got a bunch of data. Is there any way I can use that to discover a trend? And that was the genesis for linear regressions. Why do they call it regressions? I always hated that word because it sounds like we're going backward in time or we're going backwards in technology. Regressing just doesn't sound like a good word. But the reason he called it linear regressions is because when you have a bunch of data and you're calculating a trend line, essentially what you're doing is you're regressing the data to the mean. In other words, you're taking the data and you're finding like the mean trend line, and he saw this, and I can understand how he saw it this way. It's regressing to the mean, and that's where the name linear regressions comes from. That said, let's get in and look at some of the data. This first video is just talking about the data we're going to be using in these series of videos, but it's important that we see the data. Now, one of the things that we're going to be doing with the, see if I can get over and get us over to the data. There we are. There's the data. What we're going to be doing in this series, and this is a little different than probably anything you've ever seen before when talking about linear regressions, is we're going to use Excel, and we're going to program into Excel manually every single step that is required to do a linear regression. Okay? It's different. Now, in Excel, there is a package, an analytics package, that would allow you to just simply say, hey, here's my data, do a linear regression on it, and come back and it'll give you all the data, all the answers. We're not going to do that. What we're going to do is we're going to manually go through and calculate every single step. And there's a reason for that. By doing it this way, you get to learn the math behind the linear regressions. Okay? And second, you're going to get a feel for what is involved in the formulas of a linear regression and what's involved in understanding how the data impacts the linear regression. Okay? First, let's talk about the data. What I've done here is I've created here onto the left a table of purchase dates and coupon values that were redeemed and total purchase amounts. And what this is, imagine you've got a store, and in your store you've got all your clients and you give coupons out to your clients. This is for one client. He comes in on these, came in on these dates, and on some dates he redeemed a coupon, and other dates he came in without redeeming a coupon. So what we can do is we can see the amount of the coupon that he redeemed, and we can also see the total purchase amount. All right, and there's a total of 84. If you go all the way down, there's a total of 84 different dates that he made purchases. Okay, and this is the data we're going to be working with. I will say this, that this data is generated manually by my little system here. All I have to do is hit F9 and it changes the data. Now you say, well, how are we generating the data? Well, that is dependent on these characteristics up here. Now these characteristics up here I call the brain characteristics of the client. Okay, these are the characteristics that are inside of his head, except for the last one, but let me explain what they are. The first characteristic is the average purchase without coupon. Now, the patron himself probably doesn't know what his average purchase is when he doesn't use a coupon, but inside of his head, these characteristics are programmed perhaps unconsciously or consciously, but we're programming it here, okay? And the idea is these are characteristics that we want to figure out by looking at the behavior. I put them here to generate the data, but the idea is we want to really just analyze the data and see how close we can get to figuring out these true characteristics inside the guy's head. So the first one is average purchase without coupon. I set it to $100. Purchase variance. What this means is you know, when someone comes to the store, they don't always buy the same amount every single time. I guess it depends on the store, but I set this to $40. What this means is that sometimes he comes in and spends as little as $60, 100 minus 40, and sometimes he spends as much as $140. So think of it as kind of like the margin of spend around that $100. The next is the redemption probability, and this could either be how often he remembers to bring in his coupon, or it could be just simply how often he receives a coupon. Okay. Right now I set it to 50%, which basically means that half the time, half of his visits, he's going to be redeeming a coupon. The next thing is the coupon sensitivity. What sensitivity is, especially with dealing with coupons, is the idea behind sensitivity is for every dollar that the store gives the patron in a coupon, how much money, extra money, does the patron give back to the store? So we see that his average spend without a coupon is $100. So if I give him a coupon worth $12, or not 12, we'll just use $4. So let's say I give him a coupon of $4. Right now his coupon sensitivity is 3. What this means is that for every dollar of coupon, I should get $3 back. Well, if I'm giving them a $4 coupon, I should expect an additional $12 back. So instead of spending on that trip that he comes to the store, instead of spending just $100, I'm hoping that he'll spend $112. Okay? And so that's the idea behind the sensitivity. Then there's some sensitivity variance. Well, you know, sometimes he comes in with his coupon and he feels like spending maybe a little bit extra on one day and another day spending a little bit less. So there's some variance to that. Okay? And then finally, this is the one characteristic that doesn't have to do with the patron. This has more to do with the store. This is the max coupon redemption value. If the store, right now it's set to $10, which means that the max that any of these coupons can be is $10. Okay, so with these characteristics, I've set up all the data down here to kind of randomly generate. All I have to do is hit F9 on my little computer here, and it will re-randomize or regenerate a new set of data. So you can think of every time I hit F9, this is a different patron, okay, a different patron set of behaviors, because these are actual behaviors. This up here is what's in his mind, and these are the behaviors that came out of that mind. Okay? And our objective with linear regressions is to simply look at the behaviors and see if we can figure out what's in his mind. Okay? So we're going to look at the behaviors and figure out what's in his mind. Okay? That's what we're going to be doing, and we'll be doing it manually. This first graph, I just wanted to show it to you. This is just a typical graph that you might see coming out of a store. It's time-based. In other words, this is his first trip going all the way to his last trip, and these are his purchase amounts each time. And you know, you kind of look at the graph, you don't get any sense of what's really going on here. So what do? Well, let's put a trend line there. And well, the trend line helps us understand what? That we're losing money from this guy. Over time, he's spending less and less at the store. Over the course of the year, he's spending about $20 less from the beginning of the year to the end of the year. What I don't know with a straight linear trend line is this because of seasonality. Does he spend less in the winter time than he does in the summer and spring? I don't know. We could do a time series analysis, which is another future series of lessons that we're going to have, but that would help us determine seasonality. Stay tuned for that. Anyways, just from this graph, I really can't tell much. So what I'm going to do with this graph, throw it away. I don't need it. But what I could do is I could create another type of graph that would be a little bit more insightful. And that graph is what we call a scatter plot. So what I'm going to do is I'm going to highlight the coupon and the total purchase amount. Bingo, highlighted it. And I'm going to go up to my graphing. So let me show you that. So I go up here, I say insert, I go over here to my graph and click on this, and then click here on Scatterplot. Bingo, it generates a scatter plot. So let's take a look at that. Let me readjust this. Alright, so here on the scatter plot, what I'm doing is I'm plotting for across the x-axis, this is the coupon value, and across the y-axis is the purchase amount. And you notice here for coupon value 0, which is this kind of group here, these are all, each of these dots represent when he made a purchase. And if I look on a dot, it tells me that the coupon amount was 0, and on this one the total spend was $136.40. Let's look at this for this one. This one's $9 on the table. $9, $152.83. So let's go over to $9. It should be right here, and that's $113, $116. Let's go up here. There it is, right there. So that second purchase is right here on the graph, and that's important for you to understand how a scatter plot works. Now with a scatter plot, what I can do is I can go over here, I can right click on this, and I can add a trend line, just like you had added a trend line on that other graph that didn't do anything. Let me format the trend line a little bit, make it a little bit easier to see, make it red, make it a little bit bigger, and whatnot. But I can also, one of the things I'm going to do on this, and let's see if you can see what I'm going to do is show you, is I'm going to display the equation on the chart, and I'm going to display the r-squared value. And what that does is it shows me right here the equation. And remember at the beginning we talked about some prereqs for this course. You need to understand the slope-intercept formula. Well, why is that? Because the equation here is in that form, the slope-intercept. And then this r-squared, we'll talk about that in one of our next lessons. Let's get rid of this. I've already done a really nice chart over here on Scatterplot. Bingo. Now if I hit F9, notice that it changes with each set of the data. Okay? So this trend line And this formula, these are the regression. That is a regression right there. And what we're going to learn how to do is how to do this in the next videos, but we're going to do it manually. Okay? Stay tuned. Go to the next video now.